Welcome back to the channel. Today, we will explore the roles of cores in creating internal cavities, the importance of gating systems in controlling metal flow, and how to prevent common casting defects. Here's what we will cover: cores in casting, elements of the gating system, and casting defects. In casting, cores are used to create internal cavities or hollow sections within a casting. While patterns define the external shape of the cast, cores shape the internal geometry. There are several types of cores. Green sand core, made from the same material as the mold, typically used for simpler shapes. Dry sand core, made separately using a binder and then inserted into the mold for more precise casting. CO2 core, created by hardening sand with sodium silicate using CO2 gas, making the core strong and rigid. Shell core, formed using resin-coated sand, heated to create a hard and precise shell-like structure for higher accuracy and strength. Cores must possess specific properties to ensure the casting process is successful. Refractoriness, the ability to withstand high temperatures without breaking down. Permeability, allows gases to escape during the casting process, preventing gas-related defects. Collapsibility, after casting, cores should easily collapse or break away for easy removal. Strength, cores need to withstand the weight and pressure of molten metal during the pour. Thermal expansion, minimal expansion is necessary to avoid distortions in the final cast part. The gating system is a network of passages through which molten metal flows from the pouring basin into the mold cavity. A well-designed gating system ensures smooth metal flow, preventing defects. The main components of a gating system are sprue, the vertical channel through which molten metal is poured. It controls the flow and helps reduce turbulence, preventing air entrapment. Runner, the horizontal passage that carries molten metal from the sprue to the gate, designed to minimize turbulence and oxidation. Gate, the entry point into the mold cavity, allowing molten metal to flow smoothly into the cavity. Risers, reservoirs that store excess molten metal to compensate for shrinkage during solidification, ensuring that the mold remains filled. This diagram shows a typical gating system. The sprue leads the molten metal into the runner, which distributes it evenly to the gate. The risers ensure that any shrinkage during cooling is compensated for, preventing voids in the casting. The design helps minimize turbulence, air entrapment, and oxidation. Casting defects can result from poor mold design, improper handling, or issues during pouring and cooling. Understanding these defects and their causes is essential for producing high-quality cast parts. Some of the most common casting defects include shrinkage. This occurs as molten metal cools and solidifies, leading to cavities or cracks if not enough metal is available to compensate. Prevention involves using risers, a well-designed gating system, and controlled cooling. Porosity, caused by entrapped gases forming voids or holes inside the casting. Prevention includes proper venting, degassing, and ensuring adequate mold permeability. Cold shut occurs when two streams of molten metal fail to fuse, resulting in incomplete filling or visible lines. To prevent this, increase pouring temperature and ensure a smoother metal flow through the gating system. Other defects include misrun. This happens when molten metal solidifies before filling the mold cavity. It can be prevented by ensuring higher pouring temperatures, better fluidity of molten metal, and improving mold design to allow faster filling. Blowholes. These are gas bubbles trapped near the surface of the casting, often caused by poor venting or insufficient drying of the mold. Prevention involves proper venting and drying of the mold and core. Hot tears. caused by stress developing during cooling due to uneven contraction rates, resulting in cracks. Prevention includes using appropriate mold designs and controlling cooling rates to reduce thermal stress. We've reached the end of this video. Thank you for watching, and don't forget to like and subscribe for more tutorials on other exciting topics.